Hello. So today what we're going to do is we're going to talk about multi-step equations, right? So they're not going to be all that different from the two-step equations and inequalities that we've been doing, except that there's, more steps to do. So what I'll say is that right off the bat, we've got all these different steps here. We might not need to do every single one of them every single time. It's really going to depend on what the equation has for us to do. So this first one, right, we are going to be looking for a common denominator to distribute, right? The only time that you're going to need to find a common denominator to distribute is when you have a fraction in there, right? Say that we had something like 3/2 somewhere in the problem, right? If you don't have any fractions, you don't need to worry about this step, right? That's just to clear out the fractions, right? After we find a common denominator to distribute, right, if we even need to, the next thing we need to take a look out for is whether we need to distribute, right? When we're distributing, right, remember that means that we must have some sort of parentheses with a number on the outside of them, right? So whenever you have parentheses, there's a good chance we might need to do that distribution step there, right? After that, after we distribute, we need to combine any like terms that we have, right? So we might not have too many like terms, right? We might not have any, right? So again, we might be able to skip this step entirely. However, we do need to make sure that we check and see, do we have any? Right? After that, it becomes a little bit more familiar with what we were doing before, right? We are going to add or subtract to move all of the x's to one side of the equal sign, right? Obviously, they might be y's, they might be a's or b's or c's or some other variable, but you want to get all your variables over to one side. After that, we need to add or subtract the constants, right? Remember that the constant is a number by itself. We need to get those to the other side of the equal sign, right? You might notice that I put that in red and underlined it. It's because making sure that your constants are on a different side than your variables is real important, right? So put them on different sides. Last but not least, we need to either multiply or divide to clear the, coefficient. Right, and remember that the coefficient is that number that's hanging out in front of the variable. Right, so if you ever have like 3x equals 9, you need to get rid of that 3 that's attached to the x, right? Because they're multiplying, right? 3x is 3 times x. We'd have to divide to get rid of that. All right, so we're going to take a look at some of these example problems. Some of them I'm already going to have done out, right? I'll have you try them on your own. Let's start off with one like this, right? So we're going to solve this equation. What I'm looking at first off is, thinking through those steps that you've got written up above. I don't need to find a common denominator because there's no fractions, right? So we can skip over that step overall. Then I'm looking and I'm saying, all right, well, there's no parentheses. I don't have to distribute anything. All right, cool. So that step's done. Then I'm looking for like terms. And this is where people make mistakes, right? There are things that would be like terms, right? Like this 16x and this 10x would normally be like terms. This -5 and this +19 would also match up as like terms. However, they're on different sides of this equal sign, right? So what I like to do is put this line straight down the middle where the equal sign is. You cannot combine the like terms across the equal sign. You need to move them over a different way, right? So that 16x and that 10x, we can't just smush them together to be 26x. We got to move them a different way, right? So in that case, if I'm looking on the left-hand side, looking over here, there are no like terms that are just over there. Then I'm taking a look and I'm saying, all right, there are no like terms over on the right. Right? So we do one side at a time for that. After that, then I'm going to be moving my x's around. Right? I need to get all my x's to one side. So how about let's take that 10x and I want to cancel it out from the right side. To do that, I'm going to need to subtract 10x from over there. Right? Because we had a positive 10x, I need to cancel it out over there. I then also need to do minus 10x on the other side to keep everything nice and equal, right? That's what an equal sign means, is that the sides are the same, right? So you do one thing to one side, you can do the same thing on the other. So if we move down to a new line, those 10x's have canceled each other out, right? Over on the left-hand side, 16x minus 10x leaves us with 6x. And then the -5 and the positive 19 come down as well, right? So now all my x's are over on the left. I need to move my other numbers, like the constants without the variables, over to the right-hand side. So because we have 6x minus 5, right, that minus 5 is hanging out with the x's. We don't want that there. So because it's minus 5, I'm going to have to do the opposite and add 5 to move that on over. All right, so we'll do that. So again, moving down to the next line, those 5's cancel each other out. That's what we were hoping for. So all that's left over there is 6x. On the other side, 19 plus 5 is 24. Right? And then last but not least, right, we've moved everything around. Our last step is to get rid of the coefficient. Right? So this 6 that's attached to the x there. So don't forget, 6x is really 6 times x. You're going to get sick of hearing me say that, I'm sure. So we need to do the opposite of multiplying by 6, which is to divide by 6. And again, do the same thing on both sides. All right, so moving down, these 6's cancel each other out. We're going to get that x is equal to 24 divided by 6, which is 4. And that's it. Right? So it is quite a few steps, right? But if you think about it, we had to think through them all, right? Make sure we didn't have to do any other things. But we really only did like 3 steps here, right? We moved the x's, we moved the number, we divided to get rid of the coefficient, and that was it, right? Something I'll mention is that when you're doing these, I really, really encourage you to try and, like if you have another way that seems to really work for you, go for it. But setting it up kind of like I have here, keeping your work organized, making sure to keep track of where things are is real important. It's really easy to forget a piece, right? And then be like, oh man, where did that go? And then why does my answer not work, right? It might be because like you forgot to bring this 19 along. It's like, what do I put over here, So keep your work organized is the best hint I can give you. Excuse me. All right. So let's talk through this one maybe a little faster this time because I don't want this to be a 45-minute video or anything. So same deal. I'm starting off, I don't have any fractions, so I can skip that first step. I don't have any like terms that are on the same side, so I can skip that. There's no parentheses for distribution, right? So we're already moving down to moving the x's around. So I'm going to move my x's, right? That 11x, because it's positive, I'm going to subtract 11x from both sides to get rid of it from over there. All right, so again, those 11x's cancel each other out. Over on the left-hand side, that means I'm going to get 10x minus 9. And then on the other side, we're going to get negative 39, right? Be careful that there is a negative attached to that 39 there. We need to make sure we bring that along with us. After that, I now have all my x's on the left. That means that this 9 has got to go over to the right-hand side. So I got to add 9 to cancel it out over there. All right, and again, doing the same thing on the other side to keep it nice and even. So the 9's are gone. We're left with 10x over there. We're going to get negative 30 on this other side. And then this last step, again, is to get rid of that coefficient. 10x is really 10 times x. So we're going to divide by 10 to get rid of it. All right, last but not least, x is equal to negative 3. Circle it up and we're good to go. All right, so hopefully this doesn't seem super duper bad. All right. So then we get to ones where there's a little bit more going on, right? So again, first things first is I would really recommend putting this line where the equal sign is just so that you can kind of keep track of where you're working, right? And then I'm taking a look through and I'm saying like, all right, I now have a little bit more to do. I don't have any fractions, so I can still skip that first step. I still don't have, oh, actually, the next step is distribution. We do have some of that here, right? We have those parentheses on the left or on the right-hand side. So my first thing that I'm going to do is I'm going to distribute this negative 5 into those parentheses. All right. Be sure not to distribute that negative 5 to the 4, right? That is not in those parentheses, so we don't distribute to it. So I'm just going to bring everything else down that we're not doing with the distribution. When we distribute, that's negative 5 times 1 is negative 5. Negative 5 times negative 8 is positive 40, and then that x comes along. All right. After that, after we distribute, now I'm going to check for like terms. What I'm noticing is that over on the right-hand side, I've got those two numbers that I can just squish together, right? They're on the same side of the equal sign, so I'm just going to combine them. All right, so again, that 7x plus 32 is still coming down with us, right? We haven't done anything to it yet. On the right-hand side, I'm going to have that 40x, and then negative 5 plus 4 is going to bring me to negative 1. So just tack that on. Right, now it becomes more like those first couple we took a look at. What I need to do here is I need to move all my x's to one place, move all the other numbers to the other side. All right, so we're going to move that 40x over by subtracting 40x from each side. All right, and you don't have to move the 40x, right? The nice thing about these problems is that if you went ahead and did them a slightly different way, right? Say that you took this 7x and moved it over there instead, that would also probably come out fine, right? As long as your math is working out correctly, then you'll get the same answer. But with the way I'm doing it, I'm going to get negative 33x plus 32 equals just that negative 1 that's still hanging out over on the right. Now that all my x's are on the left, I'm going to move this 32 away from it. All right, when we do that, we're going to get negative 33x. The 32's are gone. And then negative 1 minus 32 more is going to bring me down to negative 33. Last but not least, again, just like before, we need to divide by that coefficient. So that negative 33 is out of there. We're canceling it out from the x's. And then x is 1. Which comes out a lot nicer than you might have thought when we were working with 33s and 32s. All right. So what I'd like you to do is try out number 4. As you can kind of see, there's a little bit of distribution down there at the bottom. So give number 4 a shot. I'm going to scroll down and show it in just a sec, so if you need to pause, go for it. And hopefully you give that a go. All right, this is how we do it. We'd start by distributing right up at the top there. We then have some like terms to combine. We then moved our x's all to one side, moved our numbers to the other side, divided by that coefficient, and found that x was negative 6. All right, so if you need to pause here and take a look and compare against what you did, go for it. It's not a bad idea. We're going to keep on going. Right, we've got something that looks like number 5 here. So for number 5, we've got distribution on both sides that I'm noticing. Right, we still don't have any fractions, so we still don't have to worry about that first step, but this distribution step is really showing itself here. So on the left-hand side, we have 7 minus, and then just in parentheses, x minus 5. So don't forget that whenever you don't have something in front of those parentheses, there is a little invisible 1 there, right? So it's that minus 1 that we're going to be distributing into those parentheses. Over on the right-hand side, we just have that 4. 4 is just going to distribute to those, and that's going to be that. So going ahead and doing that distribution, negative 1 times x is negative 1x. The 1 is optional if you don't want to write it down. Negative 1 times negative 5 is positive 5. Right. Over on the right-hand side, 4 times x is 4x, and 4 times 13 is 52. Right. So then moving right along, we've done our distribution. I now notice that I've got some like terms I can combine over on the left. So 7 plus 5 is going to give us 12. And then we got that minus 1x still hanging out. Over here we've got 4x plus 52. Right. So again, same thing as I was talking about a minute and a half ago, is that you can move your x's to whichever side you want, right? I could move these 4x's over to be on the left-hand side, right? It might be a good idea to sort of get in the habit of moving over the smaller number of x's, right? So like in this case, this negative 1 is definitely less than the 4 x's that are there, but it's not a big deal either way. I am going to move this negative 1x over to the other side though. So I'm going to add 1x to both sides. All right, so we're going to have 12. The 1x's are gone. This is going to be 5x plus 52. All right. After that, again, all my x's are now on one side. I need to move the other numbers away, which means that 52 has got to go. All right, keeping on going. This is going to be negative 40 equals 5x. I then need to divide by 5 to get rid of that coefficient. And we're going to get that negative 8 is equal to x. Right? And it's okay for your x to be on the right-hand side in your answer, right? It doesn't always need to be like x equals 2, You can have it say negative 6 is equal to x, like that, like if we had that on the last one, if we had moved our stuff differently, right? It's okay for the x to be on the right-hand side, so don't worry about that part. All right, so just like before, I've done out number 6 already. What I'd like you to do is pause here and give it a shot. And again, worst case scenario is that you don't get it right, and that's all okay. All right, so hopefully give that a shot. Right, same deal as the last one. Right, we started off by doing some distribution at the start. We then had some like terms to combine there. We then moved all our x's over to one side, moved all our numbers over to the other side, divided to get rid of the coefficient, and found that x was 10. And again, if your problem looks different for this last chunk of stuff here, right? If you moved the negative 1x instead of the negative 3x, that's okay. Your numbers might look a little bit different, but as long as we kind of get down to the same answer, right? Yours will probably look like 10 equals x. That's also perfectly fine. There's nothing actually wrong with that, right? It's okay. Excuse me. All right, so then we got to talk about fractions. So they had to come up at some point because we talked about them in those first steps. So the best thing that we're going to do with fractions is we are just going to start by getting rid of them, right? So I'm going to draw my line down the center just to keep my sides separate, just like before. But then I need to think about how to get rid of these fractions. And the way we do that is we find a common denominator. So the easy way to find a common denominator is to look at the two different denominators, right? So in this case, we have a 1 over 2, right? Remember the denominator is the number on the bottom. So there's a 2 and then there's a 5. You just take those two different denominators and multiply them together, right? So 2 times 5 is 10. What we're going to do with that common denominator is we are going to multiply everything in the entire equation by 10, right? What this is going to do is this is going to help us get rid of both fractions at the same time, right? And then we're not going to have to worry about them, which is going to be real nice, right? So let's talk through how we do that. We know that our common denominator is going to be 10, right? And I'm going to scooch off to the side because we're going to do some math on the side here. My common denominator is 10, so I know it's going to cancel out the fractions, hopefully, if we did it right. So the first thing I'm going to do is I'm going to take this 10 and I'm going to multiply it into that 1/2 x, right? We're doing this kind of distribution step here. So what's 10 times a half, right? You might be thinking to yourself like, oh yeah, well, half of 10 is 5, right? And you'd be right. Half of 10 is going to be 5, and then you bring that x along, right? But let's say that let's use this as an opportunity to kind of look at how we would do it if the numbers didn't work out so nicely, right? We know what we should get, and hopefully we can see how it makes sense, but let's see what the longer way to do this would be if we needed it. So when you're doing 10 times 1/2, right? Usually when you're multiplying with fractions, it's easiest to have fractions multiply each other. So what I'm thinking about is that 10, let's treat that 10 as 10 divided by 1. Right? That means the exact same thing as just regular old 10, right? 10 divided by 1 is 10. Then when I'm multiplying the fractions, the top multiplies the top. So in this case, that's 10 times 1, which will leave me with 10. We then do the bottom times the bottom. 1 times 2 is 2. And then I'm taking a look and saying, all right, 10 divided by 2, we can simplify that. 10 divided by 2 is just 5. Right? So that's how we can get that 5. Right? Same thing with 10 times this 1/5 that we have there. Right? So again, think about it as 10 over 1 times that 1/5 that we have. Right? The top multiplies the top, so 10 times 1 is 10. The bottoms multiply together. 1 times 5 is 5. Right? And then again, 10 divided by 5, we can do that. It just comes out as 2. Right? So this is 5x plus 2 in the problem. Right? And now we've taken care of the fractions. We do need to remember to multiply to the other side as well. So 10 times 7 is going to be 70. Right? So again, we took care of that first step, and now there's no more fractions in there, which is real nice. After that, what we need to do is we need to just solve it out like normal. This is actually just 2 steps from here on out. All our x's are already on the left. That means I need to ditch that 2 over to the right-hand side. I don't know if you can see what I see, but our answer might not come out super nicely. That's okay. So we've got 5x equals 68. Divide both sides by 5. All right, and I'm going to plug it into a calculator. All right, let's do that. So we've got 68 divided by 5. It's going to be 13.6. And that's it. And then we're done. All right. So again, the fraction ones are not super easy, right? So if you're finding this like, oh my God, what are we doing? Then that's okay, right? It is tough, right? But let's give this one actually, try this one out, right? And then we'll kind of talk through it together. Right? So if you haven't paused and tried it out yet, give it a shot. Right? I'm going to run through it now. So on one like this, I'm looking at my two different denominators, which are 4 and 3. Right? So 4 times 3 is going to give me an easy common denominator. That's 12. Right? Then I'm going to go ahead, I'm going to distribute that in there. Right? So 12 times 1/4. Right? So again, think about 12 as 12 over 1 times that 1 over 4. Tops multiply, the bottoms multiply, and you wind up with 3 if you simplify it down. All right. This middle piece is probably the trickiest part of this one. 12 times 2/3. So again, think about it as 12 over 1 times that 2 over 3 that's in there. Right? The top multiplies the top to give us 24. Bottom multiplies the bottom to give us 3. And 24 divided by 3 is 8. Right? So you can see that on this one, we can kind of suss out the first one by saying what's 1/4 of 12. But that second one, doing it the longer way, is really much nicer. Last but not least, we need to do 12 times 9, which if I remember right is 108. And then we just solve it out from there. Right? We subtract 8 from each side. Same kind of deal as the last one. We'll get that 3x equals a solid 100. We divide to get rid of that 3. And then we're going to get that x is 33.3 repeating, right? It's going to keep on going. We have a lot of 3s there forever. All right. So I know that these problems are not super duper great, but it's not a bad idea to give them a shot sometimes. Something like this, the only part I wanted to mention about it, because I know I'm already starting to run a little long in this video, right? And we can talk about the full part of this problem. I'm still going to do it before I upload the notes, but for a couple of these, I'm just going to kind of skirt right over them. The big thing to mention in this one is that, I have 4 denominators, but you might notice that some of them are the same, right? So when you're finding your common denominator, only look at the ones that are different from each other, right? We've got 3s and 5s. In this problem, that means that my common denominator would end up being 15. Right? You don't have to worry about the other 3 and the other 5 that repeat. Right? I'm also going to talk about 10 real quick. So with number 10, right, same deal. We've got a lot of different denominators here. So we've got a 3, a 12, a 6, and a 4. So what I'm here to tell you is that you could multiply these all together, right? You could multiply and get, whatever this is, 3 times 6 times 12 times 4. And you could use 864 as your common denominator. But that's probably not the best way to do it, right? 864 is a number that I do not want to work with. So what we do instead is we take a look at what our denominators are. And all we really need is for it to be a common multiple of the numbers that are there. So what I'm looking at is sometimes if you have 4 different denominators, look at the biggest one, right? Can 3 turn into 12? It's like, yeah, we can multiply and turn 3 into 12. Can we turn 6 into 12? Yeah, sure, multiply it by 2. And then can we turn 4 into 12? Yeah, all right, we can multiply that by 3. 12 is already 12, so that's pretty good. So what I'm trying to say is that you can look at the common multiples of these, right? And if you have a common multiple that's smaller than 864 in this case, then you're going to save yourself some work. Another way that you can do that is you can lay them all out in like a table off to the side, right? 3, 4, 6, and 12, right? Which are different denominators. And what I could do there is I could just, keep going up. 3, 6, 9, 12, 15, 18, 21, and so on. 4 would go 4, 8, 12, 16, 20, 24. 6 would go 6, 12, 18. And again, I'm just listing out the multiples for these. Right? 12, 24, 36, 48, and so on. So if you do it out this way, what we're trying to do is we're trying to find the number that they all have in common, and preferably the smallest number they all have in common, right? Which in this case is 12. They all have 12 in common. So that's another way that you can figure out what your best common denominator will be, is to look at the common multiples, right? So again, I'm going to go through these. I'm going to finish them up before I upload these notes, but I got one last little bit that we're going to talk about. And that's these word problems, right? So when we're setting up word problems, and I'm going to try and be as quick as I can about these. It's really just about grabbing the important information and figuring out what side to put it on. So we've got a dog breeder raising two kinds of dogs. We've got Labrador puppies and Golden Retriever puppies, and we've got some information about each one. This problem is asking us, after how many weeks will the puppies weigh the same amount? Right? So the reason I underlined those right off the bat is that we are trying to figure out how many weeks it's going to be. That's telling me that I need to set myself up with a variable, right? We'll call it W, and that's the number of weeks. When we're trying to figure out when they weigh the same amount, that means that we're going to need to make these things equal to each other. Right? So in this case, the average Labrador puppy weighs 14.8 ounces and gains 0.5 ounces per week. The Golden Retriever puppy weighs 11.6 and gains 0.9 ounces per week. Right? So one of the best ways that I found to do these is to kind of, set it up with words in a way first and then plug the numbers in. Right? So we've got the Lab puppy. We want to know when it's equal in weight to the Golden Retriever puppy. Right? So on the Lab side, that's where we're going to put those numbers that I've highlighted for the Labrador, right? The 14.8 and the 0.5 ounces. So Lab is starting at 14.8 ounces and it's gaining 0.5 ounces per week, right? So we're adding on that 0.5 on that side. The trick here is that it's every week. So that means that that's where our W needs to fill in, right? Because we want to keep repeating that process every single week that goes by. On the other side is where we put in the Golden Retriever numbers, right? Golden Retriever is the stuff in blue there. It weighs 11.6 ounces, right? So that's kind of like where we're starting off. And then we are adding on 0.9 ounces every week. So again, I'm putting my W there. After that, it doesn't look very nice because of the decimals, but this is really not too bad of a problem, right? We're going to set ourselves up with a line down the middle to keep it all separate, right? And then we solve it out like normal. So I need all my W's on the same side. So in this case, let's move this 0.9W away to be over with the 0.5W, right? And again, I'm subtracting it there so that I can cancel it out from the right side, right? Because over here, what we had was we had positive 0.9W. All right, so now this is 14.8 minus 0.4W equals 11.6. I now need to move all of my other numbers, namely this 14.8, away from where the W's are. All right, so let's go ahead and do that. So this 14.8's cancel. We have negative 0.4W equal to 11.6, just to make sure I don't mess this up. It's still a little bit early in the morning when I'm recording. 11.6 minus 14.8 is negative 3.2. And then after we get that negative 3.2, we still need to get rid of this negative 0.4, right? And when we're dividing to get rid of that, notice that I'm dividing with the negative sign as well. I want to get rid of the whole thing. So when those cancel out, we'll get just W. Negative 3.2 divided by negative 0.4 is going to give us 8. Right? And the last part of that we need to really worry about is we need to put weeks on there, right? So that's telling us that after 8 weeks, these puppies will weigh the same amount. All right? You might notice I've already done out number 12. So all you to do is try that one on your own and take a look. I'm going to be scrolling down in 3, 2, 1, right? So if you gave that one a shot, good. If you wanted to kind of follow along with what I had there, that's awesome. But I do need to make sure we keep on talking through this last one, and then I promise I'll stop talking. So one of the other ways that you might have problems set up is that they might have a little bit of geometry mixed in with them. Right? So on this one, we're saying that the length and width of a rectangle are x plus 4 and x minus 3 respectively. The lengths of 3 sides of a triangle are x, x, and x plus 6. We want to figure out what value of x, right? That's what they're asking us to find, will make the perimeters equal to each other, right? So sometimes, when it's talking about shapes and stuff and it's geometry based, it's really helpful to draw yourself a diagram real quick. So it's telling me, all right, I have a rectangle. So let's draw ourselves a rectangle. Look at that, perfect first try. It's telling me that the length and width are x plus 4 and x minus 3. Right, so if I'm thinking about a rectangle, I know that top side with the x plus 4, well, the bottom side is also going to be x plus 4. That's how rectangles work. X minus 3 on the side there is also going to be x minus 3 on the left side. Right, so we know that. The other shape that they tell us about is a triangle. Right, so we've got a triangle with side lengths of x, x, and x plus 6. And draw ourselves out something maybe like that. Sure, good enough. And again, those side lengths are x, x, and x plus 6. Right? And these don't need to be perfect, right? We don't know what x is, so we can't actually oh man, this needs to be bigger or smaller or whatever. Just draw something out just so you can kind of see what's going on with it. So this problem wants us to do is figure out when will the parameters be equal. Right? So when you're finding the perimeter of a shape, remember that what that means is that you're just adding up all the sides together. So the perimeter of the rectangle would look something like this. And don't worry about it. We're going to clean it up real nice. That means I'm going to add up all the sides. So starting at the top, we've got x plus 4. And then I'm going to add on that side of x minus 3. And then add on that bottom side with x plus 4. And then add on that last side with x minus 3. That's the perimeter of the rectangle, right? And again, we're going to clean it up real nice in just a minute. We want to know when that is equal to the perimeter of the triangle. So to do the triangle part, we need to do x plus x plus x plus 6. Right? Those 3 different sides that they tell us about. Right? So from here, like I said, we're going to make this look a lot nicer right now. On the left-hand side, right, forgot to put my line down the center, which is not super important, but it's still helpful. Right, over on the left-hand side, I've got all of these different x's that are like terms together, right? I could smush them together. I also have all these numbers. Right, we've got 4, minus 3, 4, and minus 3. Right, so we're just going to smush all those like terms together. Right, so first, the ones that are double underlined, all those x's. X plus another x plus another x plus another x. It's going to leave us with 4 x's. Right, so that's what we get from all the x's. As far as the numbers go, what might be, or the way that it works in my head that might work for you, is to start with 1, right? So we have positive 4, and then kind of just hop your way through. So plus 4, and then minus 3, now I'm down to 1. So I have 1. Now that I have 1 after doing that, I'm then going to add 4 to it. So 1 plus 4 is 5. And then we do that last part. 5 minus 3 brings us to 2. All right, so it's a positive 2, so plus 2. Over on the right-hand side, it's not quite as exciting. We've got all these x's that can smush together, and then the 6 is just kind of there. So it's going to be 3x plus 6, all right? Last but not least, we just got to solve it out, right? I'm going to move all my x's over to one side. So I'm going to subtract that 3x from each side. I'm going to get 1x plus 2 is equal to 6. And now I need to move that 2 to the other side. So I get that 1x is equal to, 1x is equal to 4, right? And then actually we're done, right? You might think oh, well, don't we need to get rid of the 1? Well, this is why the 1 is kind of optional, When we write out x, we don't usually write it as 1x. If you divided both sides by 1 here, you can do that way, if it makes you feel better about it. 4 divided by 1 is just 4, though. We're not actually changing much about it. Right? And I know that I've been talking for a whole heck of a long time, so I'm going to stop talking. I'm going to say, see you next time. Please be sure to ask questions if you have any about this, because this is a lot of stuff that we just covered. See you next time.